Good morning, everybody. 10 o'clock, and thank you very much for signing up to another one of these webinars. Today, we're going to be looking at what artificial intelligence, or AI, what it can and can't do for you from a data scientist perspective. Before we get started, I want to thank our sponsor, who is Liptrot. Liptrot are a local company to me. I know them reasonably well. They're actually one of the largest managed service providers in the UK, delivering services to multiple FTSE 100 companies. These companies retain the business of over 10% of the UK banks. Liptrot specialise in hosting IBM power systems and mainframes, along with Windows and Linux, and also fully managed SAP HANA private cloud. Liptrot's expertise and collective experience in delivering cloud solutions to IT maintenance is unmatched, in my opinion. They specialise in IBM systems, and they are delighted to be one of the IBM Platinum partners as well. So thank you very much for Liptrot. Now, could you advance the slide to 1, please, Tom?
Yep.
So, most of you know me. Those of you who don't, Tim Guest is my name. I was MD of a business-to-business distribution company specialising in the engineering sector. Prior to that, I had an IT consulting background, mainly with SAP. I now do business strategy consulting, and I love learning, particularly during this lockdown period. I did a fintech course with the University of Oxford, and I'm now doing an online program with IBM on data science, and actually getting hands-on with like RStudio, Python, and Watson Studio, and it's really, really cool. So that kind of sets me up to the reason as to why I wanted to do this webinar, because data science is one of these kind of buzzwords at the moment. It sounds like quite a cool, sexy type of role. A lot of people in businesses don't know what it is, or think, it's not for me. How are we going to make money out of our data? But when you actually scratch the surface, there's so much you can do with the data. And all businesses, whatever size you are, you'll have data, whether it's data in a database or data in images. And the more we can do with our data, the more money we can make, the more we can cut costs. And in times like this, when a lot of us are cutting costs or certainly looking for new revenue streams, data and analytics is so important. So I went to go and look for a data scientist, and I came up with Tom Liptrot. So Tom, do you want to advance the slides?
Yep.
Tom is from Manchester, which I'm proud to say was my home for 14 years, since I moved away in 2013. I do miss it, especially the beer. Tom, do you want to introduce yourself and then take over from here?
Yeah. So thanks, Tim, for that introduction. So I'm a freelance data scientist. I've been doing data science in one way or another for about 12 years. So my background's in statistics, but over the last maybe 6 or 7 years, I've been doing mostly consulting work of one type or another. So building artificially intelligent products and helping my customers to do it. I used to be the head of data science at PKI, which is a very successful AI company in Manchester. And Tim invited me to present this to you about what AI can and can't do for you. So I guess I'll begin.
Yep. Let me remove our pictures, then we can just see. Whoops, wrong one. There we go. All yours.
Okay, so I'm going to start with a bit of history. Go back in time to 1973, 47 years ago. This is sometime before I was born, and artificial intelligence had become a bit of a buzzword at that time, as it has remained at various times since then. And this chap, James Lighthill, was asked to do a review into how effective spending on research was. So Lighthill was the Lucasian Professor of Mathematics at Cambridge University, a position that has been held by Isaac Newton, Charles Babbage, and Stephen Hawking. So he was, a very well-respected mathematician, a member of the kind of scientific establishment, and he was asked to look into how artificial intelligence was going in the UK. So he wasn't a practitioner himself, and against him were the kind of AI pioneers who'd started the field. One of the most important being Alan Turing, who basically founded both the field of computer science and artificial intelligence, John McCarthy and Marvin Minsky, who were American pioneers, and Donald Mitchie, who was based at Edinburgh University at the time and was one of the leading researchers. This report was the report that Lighthill was asked to do ended up being very influential and led to what became known as the AI winter. And actually this, it became quite a sort of controversy at the time. And parts of it were, parts of the debate were played on a BBC TV program in the 70s called Controversy. And I'm going to just play a little part of that debate now. So if we go here,
I think this is where I have to help out, isn't it?
I think so, yeah.
If you click videos, there we go.
Oh, sorry. This is.
I'll begin by making a few distinctions between automation, which is replacing human beings by machines for specific purposes. That has made great progress in the 20th century, and where the replacements have been put into effect humanely has led to general benefit.
Tim, can you turn off your microphone? Because
higher standards of living. And a general purpose.
Tim, if you turn off your microphone, because it's feeding back, so we're getting a lot of feedback. I think it's coming out of your. Does that make sense? I'll try that again. Right, I'll try.
I'll begin by making a few distinctions between automation, which is replacing human beings by machines for specific purposes. That has made great progress in the 20th century, and where the replacements have been put into effect humanely has led to general benefit, improved productivity, creating higher standards of living. And a general purpose robot, an idea that has often been described involving an automatic device that could substitute for a human being over a wide range of human activities. That's what I shall argue is a mirage. Computers have been oversold, understandably enough, as they're very big business indeed. It's common knowledge that some firms bought computers in the expectation of benefits which failed to materialize. My concern tonight, however, is with the overselling of the longer-term future of computers. The scientific community has a heavy responsibility to put forward its carefully considered view of the facts to avoid the public being seriously misled. Just as the US National Academy of Sciences did in 1966 when it reported that enormous sums of money had been spent on the aim of language translation by computer, with very little useful result, a conclusion not subsequently shaken. Failures continually occurred also in computer recognition of human speech or handwritten letters, and in automatic proving of theorems in higher mathematics.
So, we go back to the slides now. Hopefully this will. So, in 1973, this guy Lighthill was very critical of artificial intelligence. He said that automation is a good thing and it works and it's useful. He was mostly talking about robotics there. But general intelligence is a mirage. So this idea that you could build a robot or an intelligence that would have general capabilities, he said that was nowhere near being achieved. That artificial intelligence and computers have been oversold, that people had said that they could do more things than they could, and that there had been many failures. So the ones that he brought up were failures in machine translation, failures in machine vision and failures in improving mathematical theorems. And this report ended up having a huge impact on research funding for artificial intelligence in the UK. And I think it was basically, there was zero funding for the next 10 years, which led to this, what became known subsequently as the AI winter. And UK went from being quite a leader in this field to falling behind. I think only one or two universities carried on doing AI, including Edinburgh University. And and I think since then there probably have been one or two other AI winters. So AI started becoming a bit more popular in the 80s with kind of rules-based systems, and followed by another kind of trough of disillusionment. And but recently there's definitely been a resurgence, so probably in the last 10 years, of interest in AI, and has definitely led to what might be known as an AI spring. And possibly even an AI summer. There's a lot of hype around about it at the moment, but it's not, and there have been quite a few successes. So if we look at the situation in 2020, it's actually quite similar to, from my point of view, to what things were like in 1973. So automation is a good thing and it works. There's lots of good examples of that where computers have been used to automate processes. General intelligence is still a mirage, so we don't have computers that can solve general problems or that can that have superhuman capabilities across a wide range of areas. AI has been oversold to an extent. People have made a lot of money, and there haven't always been returns. But I would say that the main thing that has changed is that there have been some successes. So whereas in the 70s there basically hadn't been any successes, there definitely have been now in 2020. So there's still a bit of hype, but I'd say it is a little bit more justified now than it was back then. So how has AI changed? A lot of the actual algorithms that are still form the basis of AI were developed during the Second World War. So things like neural nets, using logistic regression for classification tasks. All of these have really been about in their bare bones form for a long time. There have been a few modifications, but on the whole, the actual mathematical algorithms are quite old. But the thing that has changed is computing power. So on the left is a picture of the Manchester Baby, which is actually the first stored program computer in the world, which was built at Manchester University in the 40s. This was an amazing technical breakthrough at the time, but had in total, I think, 1 kilobit of memory, and it filled a room. Now we have 30 million times as much memory in an iPhone that can fit in your hand. This has come alongside a similar increase in the amount of data storage and a massive decrease in the price. So this is the main thing that has driven recent developments in artificial intelligence, rather than any major breakthroughs in algorithm development. Just to, I guess, clarify a bit what I mean when I'm talking about artificial intelligence before we go on. So artificial intelligence is a big kind of field of computer science that is interested in understanding intelligence and how goals are formed, how you achieve those goals, and building automated systems to do that. In the past, a lot of these systems were based on large kind of series of rules, known as knowledge support systems or rules-based inference. And these didn't, in some situations, these worked really well, but they didn't tend to have the big breakthroughs. And the big breakthroughs that have come in recent years have all been due to an overlapping field of computer science called machine learning. So machine learning works, I'll go into this in a bit more detail, by looking at lots of data, trying to learn patterns from that data using algorithms that help to do that, and to make predictions based on new data. And there's a huge amount of overlap between AI and ML, but most of the things that people call artificial intelligence at the moment are machine learning. some bits of machine learning probably wouldn't be classified as artificial intelligence, but that's a somewhat academic debate. So for the rest of this talk, really, if I talk about artificial intelligence, what I really mean is machine learning. And you may have seen this before, but it's somewhat humorous. But I've got some sympathy with the point of view that you see this crack in the wall, you call it statistics, you put a frame on it, and you can call it machine learning. And then when you're talking about it in public, you call it artificial intelligence. And a lot of the use of the term AI is for marketing purposes. It's used to get people interested, but what it generally means is that you're using some sort of machine learning, which is usually based on some kind of statistical pattern recognition in data. And there's academic debates over exactly what all these terms mean, but that's a general point of view. Okay, so what's machine learning then? If that's what we're talking about, the main part of machine learning that is of interest to you and that is used in AI systems is what's known as supervised machine learning. So supervised machine learning. So what the way this works is that you gather a fairly large amount of data that has labels on it. So say we've got data on each of these individuals, these 4 figures here, and we've got labels on them, that some are A and some are B. We can use that labeled data, so that what the information that we know about each of those individuals, to train a model that learns how to apply labels to that data. And once we've trained a model, we can use the model to label new data that we don't have the labels for. And usually that would be through some kind of probability. So we'll be able to say that this new individual on the right here has got a 95% chance of being labeled A and a 5% chance of being labeled B. So generally, the way of thinking about this is that you train the model in a situation where you know the answer, and then you use the model to make predictions where you don't know the answer. So it's about using information that you have to get information that you don't have. And that's really what all types of supervised machine learning are doing. There's a bunch of other things which I won't go into, but this is the key concept to know about. And that kind of is the main application where most machine learning has worked really well. But there have been 3 things in particular that have worked very well in the last 10 years that have generated a lot of the sort of hype around machine learning and artificial intelligence. And these are all areas where 10 years ago, humans were much, much better than computers at them. But over the last 10 years, computers have taken over human performance. So the first of these is in image recognition. So this is basically a task where you show a computer an image. It might be a dog or a cat or a horse, and you have to try and label correctly what that image shows. So people are quite good at this. They have a percentage error rate of about 5%, and in 2010. Computers were much, much worse than people at this. So they had about a 28% error rate. And this hadn't come down in quite a long time. But then there was some new techniques using what became known as deep learning neural networks, which suddenly increased the performance to significantly better than human. So in around 2014, the performance on classifying images beat human performance, and now it's quite a bit better than it on I guess this fairly tightly defined image classification task. So that has led to a lot of uses of image analysis in artificial intelligence and machine learning. The second thing that happened was in 2016, the company called DeepMind, who was bought out by Google, beat one of the world's best Go players, Lee Sedol. So Go is a board game, and it was long thought that it was very hard for computers to beat humans at it. But in 2016, using a combination of deep learning and reinforcement learning based on Monte Carlo tree search, an algorithm was able to quite comprehensively beat the world's best Go player, or one of the world's best Go players. And here you can see him looking sad because he's being beaten by a computer. So that was a big breakthrough that had probably less practical implications, but theoretically marked an important milestone. And the final big breakthrough, the one that probably I'm the most excited about, is around language understanding. So I think you will have heard James Lighthill earlier saying that there have been huge failures in machine translation. Well, only 45 years later, we've built a machine that can beat humans in machine translation. So here you can see that in July 2016, there's this score on the y-axis shows basically how well it's done. And in around July 2018, one of these transformer models, which is a new class, a relatively new class of models, beat human performance in machine translation. So this was translating from German to English. And this has led to a whole bunch of breakthroughs in understanding language by computers. And a lot of these breakthroughs are still happening. So this is still an area of research. So that's a brief overview of the things that machine learning can do. But it's interesting to look at what AI is not. So there's you do hear a lot of hype about artificial intelligence, but at the moment, there was a book written a few years ago called Superintelligence, which warned about the dangers of building super intelligent artificial intelligences that could potentially take over the world or that kind of thing. We're a long way from that. In fact, we're nowhere near that happening. At the moment, what we have are tools that can be quite good at very specific tasks if you train them and if you put in quite a lot of effort. We're nowhere near having general intelligence or anything like it. So for now, that's not something we need to worry about, and isn't something that even that many people are working on. And similarly, so that's kind of a whistle-stop tour of the history of artificial intelligence and AI. And what this talk is supposed to be about is what AI can actually do for you in a business. But I guess if we start with what AI can't do for you, it's quite can be quite instructive. So I speak to quite a lot of businesses in my role as a data science consultant, and quite often you will see, I guess, often senior managers of large companies have got this idea that AI might be magic, that you might be able to use it to solve all of your problems, to make, to do things that humans find very hard, to automate processes, and to make yourself huge amounts of money with very little effort. And unfortunately, while it is a useful tool, it's not yet magic or anything like it. And you can only solve certain types of problems, and where it can be very useful, but you can't do everything with it. So what can AI do for you? And as I said before, it's usually what people mean when they talk about AI in this context is machine learning. So what can machine learning do for you in a business? And really, when it comes down to it, what machine learning can do is it can automate and it can improve individual business processes. So it's not quite as exciting as sort of building things that take over the world, but it can be very effective. So what usually the places where I've seen it work the best are in three areas. So one is around marketing, so around personalizing your messaging to your customers, understanding your customers, recommending products to customers, and that that type of area. And the other side is around operations. So making your operations more efficient, whether that's forecasting demand, making your supply chain more efficient, or decreasing the amount of capital that you have tied up in equipment and so on. It can also be very effective there. And the third place where it can be effective, and it's a bit harder to generalize this, is around improving your product. So typically this is where your product is some kind of software-based product. You can improve the way it operates by introducing some use of machine learning or artificial intelligence to make it either better, faster, or cheaper. So how do you choose which business process to use machine learning for? So I guess there's two options. So firstly, you can use it to replace an existing process, or you can use it to create new processes. I tend to find it works best when you're replacing an existing process, because it's a simpler project to get going. But once you've done a few of those, you can start to think about bigger things. But in order to narrow down the options, you need to use machine learning for a task when it's valuable, it's frequent, you have enough labeled data, being wrong is okay, and there's no better solution. So I'm going to go through some examples of each of these now. So the first one is it's valuable. So so the main thing that you want to work out is building or having some kind of prediction valuable to you. And I've done a lot of applications of machine learning in kind of warehouse and logistics space. And a thing that I get asked quite often is, can you give us a forecast for demand for our products for next week or next month? And usually you can build something that creates a pretty good forecast for any product. But then what then tends to happen is they will say, okay, well, we've got a forecast, but what can we actually do with it? It's not valuable in itself just to have a forecast of demand. And so usually what you need to do is work out how having a better forecast of demand is going to be valuable to you. So whether that's something like decreasing the amount of inventory that you have in stock, which you can do quite radically if you've got very good forecasts, or decreasing the amount of staff that you might need to have in warehouses. You have to work out to make the increased accuracy valuable to yourself in some way. Just doing these things for the sake of it won't lead to anything. I guess that should be obvious. The second example, the second situation where you should use machine learning is when your task is frequent. So recommender systems of the type that you might have seen on Amazon have been some of the most successful applications of machine learning. They don't always go completely right. So this is an actual example from Amazon where somebody went to buy a baseball bat and found that the recommended products to go with it were a 3-hole balaclava and a meat tenderizer knuckle duster, which potentially people do buy those things together, but I don't think Amazon would have wanted that to happen. So here the data has maybe led people astray. But on a more serious note, in order to use product recommender systems, you need to have frequency of sales in one of two ways. So either you're selling a large amount of combinations of items like Amazon does, or you're selling things very often to people. So if you're selling maybe one item a year to someone, so I've worked with a small bike shop before, and if you're selling one bike to somebody every 5 years or something like that, it's very difficult to build a product recommender system. So if you're selling small numbers of high value items, you can't really look at baskets of goods, and you can't really look at people's purchase history in order to recommend the next item very successfully. But if you're selling high frequency items, like you're selling trainers or fast fashion or groceries or something like that, it's much easier to build recommender systems. So the task that you're building machine learning for needs to be something that happens regularly and that you have lots of data for, and that happens frequently. The next example is that you have to have enough labeled data. So I've done some applications of machine learning in sales, and there often you have, it depends on how large your company is, how much data you'll have, and how frequent and what high value your sales are. So particularly in things like B2B sales, if you're making small numbers of very high value sales, you won't have a huge amount of labeled data. And even in cases where you perhaps are making lots of lower value sales, you don't always have labeled data. So if you were trying to, say if you were trying to predict from the universe of UK businesses who would be likely to be your customer, you might have data on people who are currently your customers. But if you don't also have data on who you approached but didn't become customers of yours, then you won't be able to build a very successful model. So you have to have both the sort of positives and negatives present in data sets to be able to use machine learning. And often I'll see this, that people only collect data on the positives, on the things they want to happen, rather than collecting data on the cases where the things didn't happen. And that gets in the way of building a machine learning model, because you need to have both sets of labels. Another thing that you have to accept with machine learning is that it doesn't always get the answer right. So I used to work in a cancer hospital, the Christie Hospital in Manchester, where I built one of the first data science teams in the NHS. And there are certain situations where it's okay to be wrong and certain situations where it isn't. So usually when you build a machine learning model, it isn't 100% accurate. It usually gets things right more often than not, but it's not good enough to make automated decisions on. So you wouldn't want to build a model which automated your dosing or automated treatment of cancer patients, say, because if you got it wrong, you could kill somebody. But the applications that we found to be useful were things that were less critical, but still had a big impact on the hospital. So things like forecasting the numbers of emergency admissions was a really useful thing to do, because it allowed them to get staffing right and organize the beds. But if you got it wrong, if you were a couple off, it didn't matter too much. So having something that was better than chance was useful, but it didn't rely on it being perfect. And you kind of have to accept that machine learning isn't an oracle that can get everything right. And the final one is on having no better solution. And so better here, I guess, means that either it's superior, it's a better product, it's faster, or it's cheaper. And I would argue that in kind of the area of natural language processing, the kind of digital assistants that we've got, so Siri and Alexa, I'm not a big fan of these. I don't see them as really solving any problem. So if I say to my computer, hey Siri, tell me what the weather is going to be like tomorrow, I may get the answer I want, but I may not. And a much better solution for me usually is just to type it into Google and say, what's the weather going to be like? And I'll get the answer I want faster, cheaper, and better usually. So I don't think really that a lot of these voice activated systems are actually solving a problem, because there's currently a better solution is available. That's not to say in the future they won't improve, but if you've got a better solution, use it. And similarly, if you're trying to label data, if you've got people who can do that cheaply and quickly and to a high standard, then use them. There's no point building a machine learning model to solve a problem that doesn't exist. But saying that, there are applications of natural language processing that can be very good, but they're usually things like automating processes. So if you're getting a lot of customer service complaints or inquiries, you can do things like classify those inquiries very quickly, very cheaply into a high standard. using natural language processing, or which is a kind of machine learning that uses text. So there, the solution is much better, and it's faster and it's cheaper. So you have to only use machine learning when you can. It's basically when you need to. It's basically the message. So that's kind of a tour of the different applications of machine learning. And you might be thinking, now, how can I do this? And really, it takes four things. So the first thing that you have to have is data. Now, most companies collect data in some way already, so you can usually get going with the data that you have, but often you might need to start collecting a bit more data, or you might need to collect slightly different data or buy-in data or something like that. The second thing that you need are skills usually. So, I'd love to be able to do a skateboarding trick like this, but unfortunately I don't have the skills. I do have the skills to do data science and machine learning, and you'll need them too if you want to do them within your business. And that there's more and more data scientists about, but it is something that takes a long time to learn, because it's still a research. It's still something that is in development, is what I mean. So it's not. A lot of the problems aren't solved, and and a lot of the software is still young. So while there is increasing numbers of skills around this, you'll need to have somebody to do it for you. The next thing you'll need is some kind of tools and processes. So you need to get the right kind of software development tools and put in processes in place that can allow you to deploy automated solutions and even change behaviors to make these things have an impact in your business. This can actually be one of the most difficult steps, because actually building things isn't always the hardest bit. Getting them implemented within your business can be really tricky. And the last thing you need is resources. Unfortunately, these things can have a big impact, but they're not overnight solutions. They usually take a little while to get going. You have teething problems, like any project, really. But if you're prepared to kind of put in the time and put in the energy, you can have really transformative impacts on businesses with these things. So just to sum up, here's Prof. Lighthill back again, and I'd agree with a lot of his sentiments back in 1973, that artificial general intelligence is a mirage, but machine learning, when used wisely, can be really useful. Thank you. That's the end.
Right, thank you. Let's put us back on the screen. Well, I found that fascinating, and certainly the thing that made me laugh the most was the Amazon analogy. Where my mother's first experience of Amazon shopping, she wanted to buy some digital scales for her cooking, and it came up with customers also bought little plastic sealy bags, cannabis grind, and a pipe, and she's like, "What's all this about?" So I can see how it can go wrong. That was great. So if anyone's got any questions, post them in the chat. We have got one already, so I will read these out. I'd be interested in hearing how often the topic of ethics came up in your real-world interactions with clients. Sadly, there are many examples where algorithms were used in an area that affected human lives, and people have only realized the potential problems after the implementation.
Yeah, so people do think about ethics a lot in the applications of artificial intelligence, and I think that I generally think that the ethical considerations are the same when you're doing anything in a business. Is that you should consider the impacts of your actions on your customers and your users and on other people when you do AI, but also when you do anything. So I don't see it as kind of a different class of topics. In the implementations of things that I've seen, I haven't seen a lot of cases where there was obvious grounds for kind of ethical discriminations. Where the one where I have seen it and where there's been a lot of consideration on it is around recruitment. So there have been a number of high-profile cases where there was some machine learning algorithms that were used to do recruitment, which didn't work very well. So they ended up I think there was an example of it was a project that Amazon did where machine learning was used for recruitment, and it ended up discriminating against women quite heavily, basically because in the training data, most of the software engineers were men. And so it picked up on things in the CV that seemed to make it, that didn't necessarily say that the person was a woman, but their name sounded like a woman, or they went to an all-women's school, or they played, women's football or something like that, and it discriminated against them. And I have seen, so the company I did some work for last year, Arctic Shores, have put a huge amount of effort into making sure that any algorithms that they use in this space are fair. And there's a lot of research in how to make artificial intelligence algorithms fair, and it's not entirely straightforward to do it because there's some trade-off between fairness and accuracy, but there is definitely something that people are thinking about a lot.
I think that's good and also reassuring. Certainly, going back to my my SAP days when we used to walk into a business and shut ourselves in the room with the management team and show them this new system. All the employees used to get really scared, thinking, "Wow, is the computer system going to replace it?" No, don't worry. Your jobs are going to be safe. You're just going to be doing it differently, and it's going to help the company to make more money. And we had to work with the management team to kind of coach them on how to sell it to the employees, because as you quite rightly said, with any IT deployment, whether it's AI, machine learning, or ERP or whatever else, you need the employee buy-in. Otherwise, it's not going to work.
Yeah, I agree with that.
A couple of other questions. Unlike programming languages like Java and .NET, is AI seen as a sophistication rather than a necessity?
I don't know. I mean, I guess it depends. Those are programming languages, which, so it's, I guess, for most companies now, it's essential to have some sort of, software development team because most companies are built on top of software. So I guess software development is probably more of a necessity than AI. I think that in AI is, the use of machine learning in businesses is still fairly young, but all of the companies that are succeeding in the world at the moment are companies that use machine learning and artificial intelligence and data. Yeah. So if you want to be successful in the next, 10, 15 years, you've got to get onto this. If you don't, you'll fall behind, guaranteed. So whereas it might be a sophisticated, it's not an absolute necessity right now that if you don't have AI, your company will fail. But I think if you don't get onto it, you will fall behind in the future.
And I think that kind of leads us on to the next question, really. And I mean, certainly from a general business point of view, this gentleman's questioned, most companies experimenting with AI. So does the pandemic make them put this on pause? I mean, my view on this, I don't know what yours are, Tom, is that, businesses are going to need to change and adapt to the way they do things, because if you bury your head in the sand hoping this is all going to blow over, you're not going to come out the other side. So I think it's probably even going to be more at the forefront of what people do. So I don't know what your thoughts are, Tom.
Yeah, I mean, I guess it depends on the business. So if a company is already using machine learning and that's an essential part of their business, they'll be carried on doing that. So, and those will be the most successful companies. If you're not doing it at the moment, I can understand not wanting to start a new project right now. But I think the companies that are forward-looking, that are looking about how to sort of bounce back after this has happened, or looking to put in new processes because of opportunities that might have arisen due to the pandemic, will be starting to think about doing these things at the moment. So I guess it depends on how your company has been hit, and I think that the forward-thinking companies are definitely doing these things at the moment.
Yeah. Okay. There's another question here about sales forecasting. I think saying that he understands the frequency of sales, but am I right in thinking that you need a variety of sales, i.e., different products and services? Is that to build a model, presumably?
Yeah. So I guess if this is talking about building a recommender system, You need to have a reasonable number of different types of things. Not necessarily. I mean, I think if you're selling, say if you're a shop that only sells trainers, but people buy, 2 pairs of trainers a year or something, you can still do recommendations there. So, because people who bought one type might want another. So I don't think necessarily having a large variety is essential. I think if you only sell one thing, if you're a company that just sells a certain service or a piece of software, you probably can't do product recommendation, but you can do things where you would identify customers. So it's the other way around. You're kind of doing customer recommendation. You say, customers who bought this look a bit like this potential customer over here, if that makes sense. So it's kind of flipping it on its head. But frequency and amount of volume of data is really the key thing.
Yeah. And I think more because I am a trainer fanatic. I have a lot of trainers, some very rare ones actually. As I say to my wife, when I'm dead and gone, they'll be worth a fortune, some of them. But yeah, I sort of liken stuff on Instagram, and then more and more things come into my feed, and it's obviously working off the algorithm, seeing what I like, and like, oh wow, these new trainers are dropping tomorrow. This Off-White collaboration, I must have those, right? Okay, so yeah, it's scary sometimes.
Yeah.
On to the next question. As I feel that the business world, particularly finance, insurance, are jumping on the AI ML bandwagon without really understanding it, as per contracts, jobs being posted, etc. Is AI and ML leading a lot of management down a path which they don't appreciate, and what should be done to educate these managers? I do kind of agree. I mean, sort of insurance and banking and finance, a lot of it's going down that route at the moment. So interested to get your views on that one as well, Tom.
Yeah, I mean, I think there's a bit of bandwagoning going on. So I would, I've spoken to a large number of companies where I will be speaking to somebody, in some operational function who will say to me, we've been asked by our CEO to do some AI. We don't know what to do with it, but we have to do it. And that is a bit of a risk, I think. So because then you can end up doing projects that you don't really need to do. And there is definitely a need to educate managers about what is possible. So there are some things that you can do and it works really well, and there are others that you can't and it doesn't work really well. And I think that as I said in the talk, it's not magic. It doesn't solve all of your problems, but it can solve some very well. So yeah, I guess like anything that's got a bit of hype around it, you need a bit of realism, but that doesn't mean you have to chuck out the baby with the bathwater. So there is definitely benefits to it, but education is probably the best way to do that. So I guess through things like this webinar.
Yep, definitely. Yeah. And having just done a rather intense fintech program, I can certainly see how AI and ML is being used in these companies quite successfully as well. One last question, then we're going to close the chat. One area that seems to be increasingly adopting AI and ML for good and for bad is cybersecurity. Any views on the impact of how this may evolve?
Yeah, so I don't have a huge amount of expertise on this. I've done a little bit of work around it, so I probably don't have a very good point of view. I mean, I think that there's definitely potential there for automating cybersecurity. So for building systems that can proactively stop threats before they escalate and identify them. I think that whenever you're dealing with a kind of adversarial type situation like security, it's very difficult for models to keep up with the opponents. So if you build a model that can neutralize a certain threat, the next threat won't be the same. So if you so models rely on data, and so protecting against those kind of 0-day type threats is a bit tricky for an AI model to do. There are some ways around it, but I think it's it's definitely got potential, but it won't be a panacea.
One of the things that we looked at on one of the courses I've done recently was on quantum computers and how quickly a quantum computer will be able to crack even the toughest alphanumeric password. It's really quite scary. They even think that quantum computers could hack the blockchain. We're quite a long way away from this being mainstream, but it's certainly something that people are considering at the moment. And if anyone's interested, do some research on quantum computing. It'll blow your mind, as Tom will probably tell you. So, okay, that's fantastic. Questions are finished. Tom, that was awesome. I think that was really, really inspiring. We're going to be sending around a link so you can rewatch this presentation as well. I'll also include Tom's contact details in the email as well. So if anybody has any other questions for Tom, or indeed wants to ask Tom about a data science project they're working on, feel free to contact him direct. Okay, everybody, thank you very much. Enjoy the rest of your day. Thank you, Tom.
Thanks, Tim. Thanks, everyone. Bye.